Unit 3, Marginal Production and Marginal Rate of Substitution. The production department of a firm finds the following relation for the production of a model. The amount produced in relation with K and L equals 25KL minus K squared minus 2L squared, where K is the capital level and L is the working level. At present, the quantities we have of K is 5 units and of L is 10 units. You are asked the following. A. To find the marginal productivities and explain the results. B. To find the marginal rate of substitution required to maintain the current production level and explain the results. Okay, starting with the first activity. As we know, the marginal productivities are calculated by using the first order partial derivatives. The first order partial derivative of this production function with respect to K is 25 times L minus 2 times K. To evaluate this in the situation that we have, we must substitute in this function the two values that we already have. That is to say, that K equals 5 and L equals 10. By doing this calculation, we have a result of 240 units, approximately. That is to say, if we increase the capital level by 1 unit, of course, from 5 units to 6 units, the production increases by 240 units, approximately. It's very important to keep in mind that the derivatives only calculate approximate values. Okay, so we have evaluated this when the capital rises 1 level, 1 unit. So now we must try it. We have tried it with the capital, now we must try with the working level. So the partial derivative of this production function with respect to L is 25K minus 4L. To be able to evaluate this in the situation that we already have, K equals 5 and L equals 10, by doing this operation we get 85 units. That is to say, if we increase the working level by 1 unit, that is to say from 10 to 11 units, the production increases by 85 units approximately. In the second part of this question, we must find the marginal rate of substitution required to maintain the current production level and then of course explain the result. With this function and the two values that we already have, that is to say 5K and 10L, we have a result of a production of 1025 units. This isn't an immediately important piece of information to have, but of course the more information that we have, the better. So starting with the marginal rate of substitution, which we obviously know is calculated by the partial derivative of K with respect to the partial derivative of L. Calculating the marginal rate of substitution this way is the same as minus the partial derivative of the production function with respect to L divided by the partial derivative of the production function with respect to K. Okay, so the partial derivative of both L and K when substituting the variables that we already have in this production function, we have minus 85 over 240, which is more or less minus 0.354. This means that if we want to increase L by 1 unit, as it is in the denominator, we must decrease K by 0.354 units, decrease because of the minus sign, to keep the production level at 1025 units. So the marginal rate of substitution that we have just calculated is the variable K with respect to L. So to calculate the other marginal rate of substitution, which is also important, is the marginal rate of substitution of L with respect to K. This we calculate by dividing the first partial derivative of L by the first partial derivative of K, which is the same as minus the partial derivative of Q with respect to K divided by the partial derivative of Q with respect to L. By using the values that we have obtained in the previous exercise, we know that this is minus 240 divided by 85, which is more or less minus 2.82 units approximately. This means that if we want to increase K by 1 unit, which is in the denominator, but to keep the production level as it is in 1025 units, we must decrease L by 2.82 units approximately. The great John von Neumann once said, "If people do not believe that mathematics is simple, it is only because they do not realize how complicated life is."